I made this engraving. The 3D depth of the cut's actually pretty good, but I can't say for sure right now, I haven't measured it. Yeah, friends, a big hello to everyone. My name's Igor, Gravity Engraving Channel, a channel about laser machines and markers. Today, our topic will be related to 3D engraving. I really love it because we get good, high quality souvenir products. Let's start a new workspace. Our machine connects automatically. We're using images directly from Andre in Kazakhstan, so he gave us the opportunity to use images for 3D engraving, and accordingly to make very high quality, cool designs for our engraving. Right away, look, we have the circle dimensions here will be 220 by 220. We'll do a crop again, create a circle shape while holding the shift key, and set the size to 220 by 220, then press enter. We've set it in the center of our workspace. The phone's going to chirp a bit today. We go accordingly. To the layers on the bottom left, press the control key, select two objects, and go to the mask. In the mask, again, we check. If we're happy with this format, then we crop it. If not, we change the size a bit. I'll change the dimensions here, make it a little bigger, by 5 millimeters, so that we can, let's say, make our image higher quality and accordingly center it. So let's first press escape, cancel. Everything's already cropped. That's just super. Everything's fast and automatic. So regarding the image or the circle we're gonna cut, let's make the circle smaller in size, say 217 by 217. Press enter, Control Z, select in the object properties on the left side. The object list 217 by 217. Press enter, place it accordingly in the center of the workspace, so be just a little more careful. Accordingly, using Control, we select two objects and go to the mask. Everything looks good, we click Done and crop our image to this format. The coin we're using today is 25 millimeters in size. To make the image more or less interesting, we'll make this image size around 22 millimeters. So basically, we don't want to engrave any larger. In size, we won't, and we don't see any point in it. Click on Workspace Calibration. The coin is placed on a special aluminum backing. It's positioned right under the blue and red lasers. There, and accordingly, it'll be easier for the LiDAR to find its way under this coin. The next idea is that we again select drawing, hover over it, press the control key, zoom in using the scroll wheel away from us, and accordingly, place it in the area we think is right. Well, let's try to aim today, let's say by looking only at the video camera. I can't say how accurately I'll hit it. Right away, for a clear, proper setup or screen capture, you absolutely must matte the surface. Or let's say, well, give or take, so that it's more matte, not as shiny as what I have going on here, for example. And the second thing, today I made sure to clean and blow out the camera and LiDAR using a blower from the Kika company, and got, let's say, a nice clean image like this. Before that, I tried to calibrate twice, and it didn't turn out very well. So now we're taken, we definitely need embossing. It's also as simple as possible here since we'll be processing brass. I'll make everything easier. MOPA processing, and we'll leave the layers. Power, let's set the power. Yeah, we're gonna have a fun day today. 60%. Speed, we'll work at 3000. Well, at least that's what I liked. Passes, 1, we'll set the lines to 300. I'll make the increment angle 20. I won't even bother. Let it repeat. It's not a big deal. And with the Q-pulse control here, unfortunately, to get a softer material removal, you need to lower the Q-pulse control and accordingly raise the frequency range. For the frequency, we'll work around 120. Plus, we're taking our speed into account again, that is, what we'll be working from or basing it on. Here, noise reduction, cleanup, we don't really need that, but then again, we can set parameters for cleaning the material surface, and I'm not going to use that. It's a pretty interesting topic, but not today. Unfortunately, we won't be applying this. Click process. Actually, the calculation is happening during the process here. Click start. Yes, we understand that we're working without a fan. We're going to have a lot of dust and dirt from the brass today and everything else accordingly. And moving on to the engraving process. I'll probably do the engraving process with the lid closed so that all this dust doesn't fly all over the room. Naturally, I'll definitely save all the projects in the Telegram channel. I'll leave a link in the description. Everything here is as simple as possible. So we've sorted out this layout. As for the nuances of what we did here, it's actually these parameters changing the automated z-axis every 10 layers by 0.1, 1/100th of a millimeter. So it turns out, roughly speaking, we shifted by 0.25 millimeters in focal distance when engraving this object. In principle, in theory, this will be more than enough. So yeah, I mean, not 2.5, but exactly 20. 5/100ths of a nonier. So I'll say it again, this will be more than enough to get a defocus for the engraving. Another nuance, we unchecked the noise reduction box. I don't know what this checkbox is doing for us right now. Actually, no, we don't need optimization and all that. So the point here is, the downside of this function is that your 3D engraving doesn't start in order from white to black gradation. That is, let's say from gradation 255 to gradation 0, but starts somewhere in the middle and then returns to the starting point. It's not working efficiently. And another one of the changes is the automatic planning of these layouts. We've removed that and basically implemented user detection. As they say, practice makes perfect, right? So let's do... The next project is as simple as it gets. We set the focal length. While the focal length is being adjusted, I'll drop a little template in here. Okay, it's connecting. It's the same story with the template. We have the size of this layout, which is approximately, give or take, 220. Let's create a similar circle. Hold the Shift key and enter here. Let's say 217, because after all, we're still a bit short on the edges. In this case, we'll center it on the workspace. And now I'm gonna, let's say, stretch the image a little bit. I'll stretch the image without the aspect ratio lock. Grab it by the edge and pull it out a bit. Well, maybe even a little more, just a tiny bit, like this. That should work. And maybe I'd shift the circle itself a little bit over here, like so. And basically, that'll be more than enough. Now let's perform the mask clipping, meaning we'll create a mask again. Yeah, looks good. Click done and repeat the process. The size of our coin, the one we're about to engrave, is 37 millimeters. We'll set the aspect ratio accordingly and enter 37 millimeters here, hit enter, and drag it to the center of the workspace. The previous coin we used was brass colored, and it's likely brass inside too. This coin is a slightly different color. What's inside? Its composition? Who knows? Some are magnetic, some aren't. We're gonna test it now, so I'm not even sure what we're doing or what the result will be. With this material, you can see that such a massive change in size doesn't really give us any advantages, but we'll go with this fill. Again, moving on, we have the embossing mode, number of layers, and the machine power. We'll run it at 65%. It gets very hot. The speed is 3000 millimeters per second. We won't go any higher for now, though maybe we'll test it in the future. One pass, set the number of lines to the maximum of 300. That gives us a value of 0.033 millimeters. Is that a lot? For brass items, it's actually not enough. I'd actually do it at 0.02 or 0.01 millimeters. But here we're getting, roughly speaking, 0.03 millimeters. The auto rotation angle, we'll set to 20 degrees. You can also do it with small passes, but I've decided to work in this mode. So automated z-axis, we repeat the procedure every 10 steps. We go down by 0.1, ending up with 0.25. Roughly speaking, hundredths of a millimeter. Well, let's say I don't like it. Let's test a 0.5 millimeter depth, meaning the focus shifts specifically down the z-axis, or let's call it the automated z-axis. This function turns on automatically again, so we turn it off. Definitely don't use it. We don't need to use cleanup here either. There's no point. Later on the piece, I'll apply a chemical patina and process it manually on a polishing machine. User defined, thank God the function was saved. So next in our process is to hit process, and all the layers are calculated. A notification about the missing fan will pop up now. Well, that's expected. You should understand. And so we confirm it here and confirm it on the main screen. This pop-up message saying that the fan is missing is a downside. Possibly because when starting the machine, we reset this missing fan function and we don't get the info. Total time and time elapsed. The total time just ticks away during the work, but on this screen we have the total time of the engraving process. Moving on to the engraving process, and at the end we'll look at all the models and how they turned out, how high quality, good, and detailed they ended up being. And of course, all of this was after post-processing. Let's wrap up with the final results. I'll say right now, I'm a bit tired, I might stumble over words or talk nonsense, so please be attentive and careful. The engraving on our first item, this brass disc, 25 millimeters in diameter, it was sanded and polished, and I've drawn some conclusions. A speed of 3000 millimeters per second is a bit much. The fill density is at its limit, which is 300 lines per centimeter. That's about 33 thousandths of a millimeter. Of course, that's not enough. Ideally, it should be 0.01 millimeters here, which works out to, roughly speaking, 1000 lines per centimeter. So, well, in principle, it would be quite good. If we had those specs, and working with brass would be much more interesting. You could increase the speed by raising the fill density to get a cleaner engraving. Actually, without making conclusions here, we did a second engraving on this Chinese washer. The washer is made of some alloy, but I don't know which one. The quality is terrible, but it engraves. More or less like brass, well, a bit worse than brass. It's made from all sorts of scrap waste, because some washers are magnetic and some aren't. So the composition includes iron and, well, production waste. That also needs to be considered here. The sampling depth is small. We have the option to lower the z-axis by a set amount after a certain number of passes. The set value cannot be less than 0.01 millimeters, which is exactly what we used. With every 5 layers, it drops by 1/100th of a millimeter. Basically, well, in this case, it all worked out quite well. Again, I'm tongue-tied. It's getting late. Today we engraved for a long time, a lot, and effectively. So after drawing some conclusions here, well, again, a few conclusions, I decided to use a different blank and see. It's made of metal again, or whatever. Maybe it's like copper plated. Actually, it turned out to be the same composition inside and out. So what it's actually made of is unknown. It doesn't engrave or polish like copper. It's a very hard material. I can't say what its composition is. We also did it at 3000 meters per second. The maximum density was 300 lines per centimeter. This is the result. We applied a patina with a chemical that works specifically on copper. It turned out okay. I polished it, and again, I used white Dialex finishing paste. It was all very difficult, tedious, and slow. I didn't really like it. Dialex paste is very hard to wash off. I usually use gasoline with oil for cleaning. Then the process is more or less effective. So after drawing some conclusions, tweaking the settings, lowering the speed, and increasing the power a bit, I repeated the process and made this engraving. The 3D depth of the cut is quite good, but I can't say for sure right now. I haven't measured it, but the relief is there. So with an image diameter of 37 to 38 millimeters, we get a pretty good 3D engraving, which then polishes up quite well with GOI paste too. So you don't have to use Dialux, we use GOI paste specifically, which I was actually happy and satisfied with. Applying these effects here, I moved on and made the same alien, but this time with a deep material cut. Each engraving like this takes on average from 1 hour to 1 hour and 20 minutes. The cut here was, of course, very good, right down to a depth of about 1 millimeter. The thickness of these blanks is a bit over 3 millimeters. I think 3.5 millimeters. The diameter of the blank is 40 millimeters. Well, basically, it's like a metal, so you can basically use them for things like that. So, for context, yeah, cool, neat. It's doable. Production time, here we spent 26 minutes. Here, for some reason, it only took an hour. Wait, an hour here? Even though the area increases, well, not double, but much more. So, moving on. Actually, 3D engraving works quite well. It just needs a bit more line fill density. Plus, there's a small thing. We don't have to set the laser. NTC, Polygon TC, jump speed, it's all preset by the manufacturer. So we load the image, set the parameters we need, and then just keep working. You need to uncheck some extra boxes. They interfere with the engraving. If you watch the video closely, the time lapses again, I think you'll see clearly that I made a mistake somewhere. I didn't use MOPA IR, meaning infrared, but used the blue laser. Yeah, it's a bit unusual working with a machine that has two different built-in lasers, and the first one is always blue for some reason. That's it, guys. As always, give it a thumbs up. More interesting stuff from me, more goodness, cash in. Bye bye, everyone.